professor in the physics department at Purdue University, and also work with people in the Earth, Atmospheric, and Planetary Science department, as well as civil engineering. We do a lot of modeling on how fractures affect wave propagation, which is a code written in C++ by my students. Even though I don't know C++, I'm still able to use the code and get out really interesting results. And we also have deformation codes and, again, fluid flow. Modeling helps me study very specific problems so I can understand a complicated real-life situation. So we have fractures in rock. We know they have certain geometry, but often I want to know, well, if it had this very specific geometry, would it show the same behavior as this very similar one? And so I use modeling as a way to teach myself of how certain geometric features or aspects of a problem contribute to your overall behavior. In the past, I programmed in BASIC and in a language called Pascal, and then in Fortran, and then IDL. And the reason I've programmed in all these different languages is because over time, as we've gone from mainframes to personal computers, now to cloud computing, the languages that you use change. So I've learned to program in different languages over time, and you find that once you learn one language, it's very easy to pick up another one. And usually the main difference is input and output of your data. I would go back, I think it was around 1984, 1985. We had our first Macintosh computer, and the only programming language they had at the time, we knew Fortran, but they didn't have Fortran for the machine yet. They had Pascal and C++. We always wish that we had chosen to learn C++ first instead of Pascal. So that would be my message.